let's practice solving a triangle using law of sines. First, identify the category of the triangle given, then solve the triangle. We're going to round to the nearest hundredth when reporting values were applicable. Now, the two types of case 1 triangles are either ASA triangles or AAS triangles. Now, ASA triangles, we found, are the given information includes 2 angles and their included side. For an AAS triangle, it's still 2 angles, but now the side is not the one that's included between them, but one of the corresponding or opposite sides to one of these angles. So let's identify which type of the case 1 triangle we are given down here. We are given 2 angles, so we're definitely in the right spot. And I notice that alpha and A go together. So because one of the corresponding sides is included to one of the angles, this is definitely an AAS case. I can draw out kind of a sample triangle that kind of helps me visualize what we've got going on here. Try to avoid drawing a right triangle since these are what we call oblique triangles. And I can draw these in any order in terms of the alpha, beta, gamma, etc. But when I draw in those opposite or corresponding sides, the A needs to be across from alpha, the B needs to be across from beta, and then the C will be across from gamma. I'm going to go ahead and just highlight what I've been given. I've been given alpha, I've been given beta, and I've been given a little a across from that alpha. Okay, and you can draw them in if you want. You could say, a equals 3. I could draw in this beta, make it a little longer there, 75 degrees, and then draw in my alpha, 39 degrees. And now I'm ready to go. All right, what else do I need? Well, it looks like I have 2 angles, so finding the third angle, I actually don't need the law of sines. I can just solve for the third. I know that 3 angles in any triangle add up to be 180 degrees. So this will allow me to solve for my gamma here. So if I take 39 and 75 together, I get 114. So I'm going to go ahead and write that. And then I can just take that away from each side. And so this should leave me with 66 degrees over here. Okay, so this was me, maybe I'll just kind of label this up here. This was me solving for gamma. And now that part is done. Okay, so what else though do I need? Okay, so that part is done. But now I still need this C and this B right here. So how can I solve for those? Well, I can consider using law of sines. Law of sines says I need 3 out of the 4 things. Well, law of sines is all about my angle and corresponding sides. So I do know my alpha and A, and then I do know my beta, and I could use those 3 to solve for B. So I'll show you what I mean. So if my intention is to solve for B, okay, then I can use sine of beta over B equals sine of alpha over A. And then let's think about what of those things do I know? Well, I know both alpha and A, and I know beta, so that's 3 out of the 4 things, and I can use that to solve for B. Okay, so I'm going to plug in my values now. Okay, so I'm going to have sine of 75 degrees all over B, that's what I'm solving for. Alpha is 39, so sine of 39 degrees all over A, which is 3. And now I don't want to use my calculator until the end, so I'm going to kind of hold off until I can isolate B. So what I can do is actually cross multiply here. So I'm going to get 3 times sine of 75 degrees equals B times sine of 39 degrees. And then I'm going to divide both sides by sine of 39 degrees. And so that means that this whole thing on the left is what I'm going to put in my calculator. Okay, I'm using the Desmos Scientific Calculator. And if you put the division symbol in first, so I just clicked on the division symbol, that's going to help us. Notice that I'm in degrees, so I have my degrees switched on. And then I'm just going to enter what goes in the top. 3 times sine. So where does sine? It's just already showing. Put in 75 right there. If I close the parentheses, it's happy. And then at the bottom, I want sine of 39 degrees. So I just go sine of 39 degrees and then enter there. And then notice that it says, hey, you've got something going on over here on the side. This is your answer. It said round to the nearest hundredth, so I have 4.60. So B is approximately 4.60. Now, in case I somehow mess that up, I don't want to use that value unless I absolutely have to solve for C, which is my last one left. Okay, so the last thing to solve for is C, and I'm just going to use that same sine of alpha over A as one of the sides for my law of sines. And then if I want to solve for C, then I need to know gamma. So sine of the gamma all over the C, which is what I'm after. So let's make sure I know 3 out of the 4, and you can just start by plugging those in. So I'm going to have sine of 39 all over 3 sine of, now gamma we did have to solve for, so we could always just double check that, but most likely we're in good shape, just because it was just kind of our simple math there. Okay, sine of 66, what we found for gamma, and then all over C. Okay, and then I'm going to go ahead and solve for C. So I can still do that cross multiplication, gives me C times sine of 39 degrees equals 3 times the sine of 66 degrees. And I don't want to be too lazy here, so I'll add in my little degrees up here. Oops, I don't need one there, but okay, we got those ones. And then I'm trying to solve for C, so I need to divide by the sine of 39 degrees on both sides. Okay, then I'm ready to put this in the calculator. 3 times sine of 66 degrees all over sine of 39 degrees. Notice that I can kind of hijack what I did before and just put in my 66 here, and then I get 4.35. So then I think I'll have found everything I was after. So I was after this gamma, my C, and my B, and that is here, here,